My name is Sadiq. I'm a data analytics customer engineer at Google. I have about 13 years industry experience, and I work with Google's customers to help them build data workloads on Google Cloud and other clouds. I have worked across different geographies from Nigeria to Portugal and now in the UK, and I'm happy to be here. So the agenda for today is we're going to be looking at Apache Beam, and we're going to be looking at Apache Airflow as well. And hopefully you would have some time to run some demo. I need to time myself. I know we're starting a little bit late. And hopefully we'll run some demos. And for us to be able to do that, please, I need like 2 or 3 or 4 volunteers, people with laptops, who could go on a website, just my website, sadiqakintola.com, and you will see a file, you would see a link to test this demo. So I want us to test this demo together. Basically, what we want to achieve in this demo is we're going to fill in maybe just like a name, or number, just any number, 1, 2, 3, and then email address. That one is, email address, and then location. Any location is fine. You can put Sunnyvale, you can put San Francisco. Just make sure you put a real location, because at the end of the day, you will see Gemini, which is Google's AI model, in action. They'll be able to send you an email and give you just some bit of information. So go on the website and you should be able to see Beam Summit's demo. You'd see that link there. Okay. What's the motivation for this talk? The motivation for this talk is earlier this year, I was in Pittsburgh, and I attended the PyCon US, where we had fantastic people in the room where we're discussing Python. Then we had the opportunity to actually talk about what we use Python for. So I came up with this idea of using Python with Apache Beam and Airflow, and the discussion was so nice. And also with the fact that I work with customers, and some of the things that they do or they try to do is they have different workflows, they have different pipelines, and they want to build a workflow from these pipelines. And one of the problems is, how do we kind of put these things in sequence, and how do we arrange these things together? So I decided to come up with this topic and hopefully build a demo around it. So hopefully you'll enjoy it. Okay, so before I start this session, I really want to explain some basic concepts around, Apache Airflow and Apache Beam. So basically, if you're, as data engineers, if you want to build your data engineering pipeline, there's some basic things that you expect to be in place. Other than being able to move data from point A to point B, you also want to be able to do scheduling, organize your dependencies, do error handling, so that when you have errors, it doesn't affect the whole of your pipeline. You're able to keep those things in check. You also want to have a bit of understanding of what's going on through reporting and connectors. So these are basic things that you need from an end-to-end pipeline. Some of them you will not get with your regular tools, and that's why we have to understand some of those concepts. There's another thing that I want to explain, which is we all know that we have real-time streaming, and we also have, batch pipelines. But batch pipelines is like in 2 modes. There's scheduled batch, which is sometimes what we do, especially for maybe some cron jobs that we need maybe at the end of the day or something. So we know the exact time that we have to run these pipelines. But there's also a triggered batch, which is something that we'll be working on today. Basically, it's around, something happens, and because that thing happens, you want to launch a sequence of other activities. So some of the customers that I work with, because it's business dependent, you'd have to initiate some certain actions because something has happened, and that's why we're working on this today. There are certain tools that you can use, especially in the open source community, but on Google Cloud, there are some specific tools that you may find very important to use them, depending on the kind of process that you want to run, whether it's real-time, it's batch, or it's scheduled batch or triggered batch. With triggered batch, you probably have some couple of tools, but you would most likely use Cloud Composer. If you're still very much around the open source, you can easily combine this with Apache Airflow. So it's either that or this. Then you can use Cloud Functions. I use Cloud Functions with Cloud Composer, which is a managed Airflow instance. So we would see that in action very soon. So challenges in orchestration. One thing that data engineers don't want to do, or a situation where they don't want to be, is to have a life that looks like what you have on your right. It's a mess. You don't want it to. You don't want to be in that situation where you have different things coming. It's working, but you can't sit down and read exactly what is coming from where. So you really want to avoid this at all costs. And how do you do that? You do that with orchestration. So there's orchestration need in building your data pipelines. So it's not just about moving data from A to B. If you look at this cluster of wires, I mean, it's coming from somewhere and it terminates somewhere. Obviously, it's doing its work, but this is not the way you want your pipeline to be like. So you really have to, you have the orchestration need, which is a pipeline orchestrator managing, scheduling, monitoring, and dependencies to ensure smooth flow of your data. So now, having understood all these needs and all these areas, we have to understand some basic concepts. And we have Apache Beam, which is basically the tool that we use to run our pipeline from end to end. The B in Apache Beam is from batch, and the EAM in Apache Beam is the stream. So that means this helps us to do batch and streaming of data. I love this tool so much because it just empowers you to do a lot of things without sweating so much, because it gives you the power to use existing tools that you already know how to use, Java. So basically, it's one model. It's the Beam model. And then you have multiple modes, which is batch or streaming. You have your SDKs. So whatever programming language that you're confident in using, whether it's Java, whether it's Python, whether it's YAML, whether it's whatever, you can actually use that. And you have the option on, you can spin up your own clusters, run Apache Beam on your environment, and then use the local testing to just run your Beam pipelines. If you want a managed service, you can use something like Google Cloud Dataflow, which a number of my customers actually use. So basically, it makes life so easy by giving you multiple options on different levels, so that at the end of the day, you're able to ride on whatever we've rocked your boat. Now, I would probably not want to spend so much time because I believe that I'm speaking to people who are not that beginner level, definitely. So we're probably advanced. So a number of those concepts, I'll probably skip them. But it's important to reiterate that we've got something we call pipeline, which is, your end-to-end, what happens between your end-to-end from start to finish, from your inputs to your output, and then everything that happens in between. We've got P collections, which is like the collection of your data sets and how you manage them across different places. We got P transform, which is like, how you convert your data from one point to the other. There are kind of some technicalities around this, but just kind of simplifying it so that we understand what this means. What transform is, transformation. So it really means what it stands for. These are some deep dive explanation into what a pipeline is, what a P collection is, and what a P transform is. But really, if we need to kind of explain, please just call me back and I would probably put more explanation to it. Now, the question is, why do you have to run Beam on Cloud Dataflow, on Google Cloud as Cloud Dataflow? Obviously, you would get everything that you need from Apache Beam, but you get more. And the more is you don't have to manage your resources in terms of separating compute from storage, in terms of log collections, monitoring, auto healing, and IO optimization. All those things come when you out of the box when you leverage the Google Cloud. And more importantly, you're actually able to integrate with other services on Google Cloud Platform. Let's say, for example, you're able to get your data into GCS and probably use some other services like Cloud Functions or other services, and then direct your thing into BigQuery, all on Google Cloud Platform. And your data is actually not moving outside of your infrastructure. So it makes life a lot easier, gives you security and a lot of things that you can benefit in addition to that. Now, the same thing, I'll probably want to skip this on Apache Airflow, which is explaining the basic concepts. There are some basic things that you should understand in terms of Apache Airflow, or just a quick one. Apache Airflow is an open source workflow management platform for data engineering pipelines. It's about 10 years old. So next week, we will be celebrating the 10 years of Apache Airflow and the Airflow Summits. So if you're available, you should join us. And there are some basic principles, things that you should understand with Apache Airflow, which is the Python file, the DAG, especially the DAG, which I would really, really spend some time to try and maybe explain a little bit, just to give us a good understanding of why it's needed to run our Beam pipelines. Then we have tasks and operators, which are also very important. Now, I give some definitions here, which I'll probably not go into, but I want to double click on the DAG itself. So it's directed. The connections between tasks have a direction, meaning Task A must complete before task B starts, establishing a clear sequence of execution. Then acyclic means there is no loops. Once a task is executed, the workflow doesn't return to that task. It progresses forward. And the graph part of it is the DAG is essentially a collection of nodes and edges. So really what this means is you start somewhere, you finish somewhere, and in between there are some dependencies, and you have to make sure that you codify those dependencies in such a way that satisfies what you want to do in your pipeline. Again, why should you use Airflow as Cloud Composer? It's the same thing. It gives you extends what you have already and then gives you more by leveraging Google Cloud Platform and its resources. Now, like I said, I have prepared some codes to explain this concept. So I would welcome you to, but before, do we have anyone that have submitted anything on the, okay, we've got some files, but in case we haven't gotten some files, I can try and probably upload some myself, but I'm sure those people that submitted some files would get. So I've got some files in my test files, right? And I'm trying to upload them from my environment just to be sure that I have files in my pipeline. The reason why I'm doing this is if there are no files, okay, so I've got new files now. Okay, so I've just uploaded these files. Okay, now the files are gone because my pipeline has started, and I'll explain what happens behind the scenes. So initially we have 8 files in this GCS folder. Okay, someone just uploaded one now. And when my pipeline starts, I want it to have at least 5 files so that I don't, I have to be watchful of my credits. So I have to have at least 5 files before I trigger my DAG to start running the pipeline. So I've made that to happen. If you keep adding files to this folder and it becomes 5 of them, the pipeline restarts again and takes the files and start working with those files. So if you want to keep trying, you can try. Now, going back to the code review, now I start with the Beam pipeline, right? The first thing you do with the Beam pipeline is importing your libraries and reading the files. So basically, like I mentioned, if you go to that website, you would see the structure of the files that I need. What I need from this is the name, the email, and the location. So basically, I'm reading all those 3 elements, and then I'm reading them into my Beam pipeline using this function called process, right? Read and validate CSV file. So basically, it does that. The next step is, okay, now that you've read these files, I want you to do some additional things. The first thing is, can you add a timestamp? You know that no one added a timestamp into that file. I add a function to help me kind of add the time that, that process is happening. And the next thing I want to do is, what I'm trying to explain here is, you may have a set of works that come by default, but then within your pipeline, you're able to add 3, 4, 5 more. And at the end of the day, this is what we call P collection. So I have 3 records, which I have 3 details: name, email, location. That's a P collection on its own. Now it enters into my pipeline. I add a timestamp. It gives me another P collection with what I have. And then that's how I keep building on that. Now I've added my timestamp. I'm beginning to build my pipeline. And at the end of the day, I bring it all together, all those things that I've done, which is matching my files, reading my files, adding timestamp, and eventually putting this thing into a sink, which is BigQuery. You would see that I've defined my BigQuery, which is in line 7, Beam Summit 2 2024 Airflow, and it ends with registration. That's the table. So that's my data set, my project, my data set, and my table. So that's the sink. And at the end, at the right-hand side, you would see the structure of the BigQuery environment. So at the end of the day, my BigQuery environment has name, email, location, timestamp, file location, because I wanted to read where is the file, what's the name of the file that you uploaded. Then there's a flag there, which is sent email, which helps me essentially to know has an email been sent to the person who uploaded this file. So basically, that's my Beam pipeline. This is a structure. On the left, you have the structure of the GCS buckets before running the code. And essentially, you see on the interface, on the web interface, where it was showing 8 files. But when the pipeline started, it actually turned into 0 because now it has been moved. At the end of the day, once the pipeline is finished, everything moves into completed runs. And that's the archive folder. So that's my Beam interface, and that's my GCS interface. So it shows the full folder and the empty folder when it's finished. But this is actually the results. So on the top here, on the top left, you see the number of runs that I have in Beam. At the bottom left, you see the execution of what all those processes that I've mentioned, those execution, how it has traversed my pipeline. And of course, on the right, you see the results in BigQuery. So basically, this is the end-to-end of Beam working on its own as a standalone. Now, let's see how we've been able to trigger this with Airflow. So I would review the Airflow code as well. Again, starting with the libraries, you have to import certain libraries that you've been able to use with your Airflow pipeline. And then one of the most important things is to define the DAG. Make sure you give it a unique name so that you're able to identify it when you get to the Airflow interface. One other thing is, because Airflow is on Composer, you don't have a console or a terminal where you can install things. So you have to notify through the environment saying, okay, I need these packages to be installed in my environment. So if you look at the bottom right, you see SendGrid and Google Cloud AI Platform. That is because I'm using these two packages to send, I'm using them in my pipeline. I'm calling those packages in my pipeline. And on the top right, you'd see that I have a SendGrid API. Because I'm using SendGrid API to send my messages, I have to have an API key. So that's where I store my environment variables. Again, some concepts about Airflow, you have to use operators a lot. Anything you want to do, you want to run a bash, you have to use bash operator. You want to run a Python, you have to use a Python operator. You have to do anything, you have to use a corresponding operator for that task that you want to do. Otherwise, there is no way. There's something that we call XCOM, which is really, really important in Airflow. So let's say, for example, I have task A, B, C, D, and E. Now, task B and C have to exchange information. So once I finish running the task on task B, the information that I have from task B, I want to pass it into task C. The only way, well, one of the ways that I can do that is using XCOM. So B will do an XCOM push, and C will do an XCOM pull. If I'm not using it in task C, if I'm using it in task E, E will do the XCOM pull to be able to use the results of the data that I have in the previous push. So it really makes life a lot easier for you to do. Now, if I have not said anything since I began this talk, and I just explained this line of code, I think my job would have been done, because this is the reason why we're here, which is, running your data flow or Apache Beam code inside of Airflow. And this is the way you call it. You use a data flow creates Python job operator. Like I said, you have to master your operator to be able to use these things. You define your task. You also mention the location of your files. So I put my file inside this GCS bucket, as you see in line 4. And at the end of the day, I mentioned some other important options that eventually comes together inside this job operator and makes that Beam task. Now that this has been called, that means it could run essentially the same way I would trigger a pipeline run inside of Apache Beam. So now, once this has been run, I need to talk to BigQuery that, I have a set of records that have been, pushed into BigQuery, but I need to act on them. How do I do that? And this is where XCOM comes into place. So I do like a select query. I try to fetch those records from BigQuery. Now that I have them, it puts them into a data frame for me, and I can use that. Now, this is where I called Gemini. So I have on line 2, I described this location. On line 4, I called the Gemini 1.5/001 just to help me, as I've said on line 6, tell me fun facts about the specific location. Remember, I collected location as part of the items that you supply in the CSV file. So I use that item and I kind of run a Gemini model on top of it. And once that is done, I'm able to get that and use that to prepare my email. So with my SendGrid API, I can call my describe this location and then fuse that into a send mail function, and it will help me to send that email. So most of you that have filled that, I'm sure it must be more than 5 minutes. I think the pipeline runs for 5 minutes. You must have probably seen who has got an email notification. Good. Thank you. So then so now that email has been sent, I need to talk back to BigQuery to update those places that I've sent, those respondents that I've sent email to, just to update that flag. And so once it does that, it just runs and updates query, and that is done. The final step is, to set up the dependencies. So you would notice that when I started, I mentioned that if I don't have up to 5 files in my Google Cloud Storage bucket, I don't want this to trigger. So for that, I have to have like a dependency set for that. So the first thing is check the files. If it's insufficient, then end task. That's what you have on line 19. So on line 20, this is the one that does it end to end. So you check the files, move the files to where I can run it, run the bin task, do the BigQuery thing, update the BigQuery, and then move the files to archive. So basically, this does it end to end. Finally, I didn't do all this on my own. I actually use Cloud Functions to trigger when there's a new file inside the GCS bucket. So you will see on the right side on line 30, that's where I defined my web server on Cloud Functions to trigger the DAG that is mentioned on line 33. So that way it knows exactly once Cloud Function has the capability to know if there's a new file in a bucket, trigger anything. And in this case, it is my Airflow DAG. Now, this is the results that we have. This is my Airflow environment. You see the runs and you see the progress of the run. And at the end of the day, you see the email, which is the result of what most of you probably have now. Now, there's something I need to mention. You probably would say that, okay, if you can do a lot of this task inside of Airflow, why not use Airflow to do it end to end? See, there's a limit to what Airflow can do, and you should respect that. The fact that it can query the data in BigQuery and it can, update the data in BigQuery or fetch data from GCS or whatever, doesn't mean that it is meant to do all this job end to end. You have to know exactly what the limit of Airflow is and not give it more than it can do. Besides, you have to remember that Airflow is just an orchestrator. And I think we've been able to do the demo, but if you want to, please go ahead, go to the repo, download the repo, try and improve it and see what you can do. I have put some useful resources in case you need them. And last thing I would say is, please don't forget to join us at Airflow Summit next week. And if you need to talk about this, please reach out to me. Thank you very much.